Hi again. Yeah, I'm happy here to present my thesis work and to give you an overview of the plan. I'm going to start with the motivation why we've chosen this domain, the methodology that we follow to the problem setting, the proposed solution that we research in our thesis work, also related work to this one, data sets, experiments, results, conclusions, and the future steps for future work. So to start with, 2024 has already been named one of the biggest elections here in history, and more than 60 countries across around half of the population are holding elections. This means that there is a major threat and testing for democracy health that is currently happening. And in the recent years, we have seen a lot of examples that there were several manipulations in electoral campaigns that took place, and they were targeting to manipulate with the society's view and to take some certain position. So that's why we think this is a very important topic to be studied and to researched. And also what is more important, that these influence campaigns, they take place usually in social media, and social media is currently also becoming a huge source of the information where we're getting all of the news from. Um, and what is also more important, that the neutral facts and journalistic standards that actually support this neutrality is not that important as the experts and influencers and bloggers that are setting the source media and trying to present their information and to also add some additional interpretation to the news that are currently happening. And in that case, the malign actors that might be having their own interests, they are finding this kind of setting very appealing because you can try to set this malign network in order to influence the audience opinion and manipulate with it. In this methodology, we comply with the methodology from European External Action Services. They actually define the FIMI actions, or foreign information manipulation and inference. It's characterized as a behavior that can potentially impact the values and political processes. They are also of intentional and coordinated manner, and actors can be involved in both state and non-state actions, and it's including the proxies that can be set inside or outside of their own territory. And early detection of such incidents, it's a kind of only way how you can mitigate their impact and to promote for critically engaged audience. In our research, we're gonna address the FEMA actors or FEMA actions as malign. And one of the ways how these malign actors can work with the audience is they can appeal to the emotional triggers the audience can possess. There were discussed several techniques for manipulation and propaganda that already use the appeal to emotions that a person or a group of emotion have. So this is a known technique that can be used. And also in general, malign actors have a good knowledge of their audience and their emotional triggers because they are kind of more closer to the state on the territories where they're acting. And in that manner, programmatically solving this task and helping to identify these emotional triggers is hard because of this good knowledge that is required and also subjectivity that's involved in this task. So in our problem, we decided to focus particularly on this task of emotional triggers detection in social media publications. And in particular, we're interested in how you can take into account this context a particular person or group of people have that highly affects their emotional triggers that they have, and how these contexts they can be transferred from one task to another task, and how it can be used for different countries and not for only one specific solution. And in our case, because we're talking that emotional triggers are specific to some specific context, we decided to go for the segmentation that's already present in one country. This is demographical segmentation. We want to use it as an approximation for the context of the group of people of a particular country. And in the same manner as LLM are using the context, we're using this context in LLM inference in order to improve the emotional triggers prediction task. And what else? We also try different algorithms and approaches how we can improve this impersonation, including the zero few shot learning and also the fine tuning of the model. So I talked a lot about emotional triggers. We actually defined our own model for emotional triggers and consisted several factors that we wanted to take into account, starting from the general emotion from 6 categories: anger, fear, sadness, surprise, love, and joy. We also have the emotion class, which can be either positive or negative. We don't apply any prior knowledge of these emotions because we believe that there's some subjectivity and there can be different classes for different emotions. Also the trigger level, which is kind of important in our case because it's again subjective measure of how intensive the trigger of the person or group of people might possess. We define it from 1 of low to 5 of high. Also, we detect the trigger phrases in this particular text spans that are triggering this particular emotion, and the description is a general explanation for elicited emotion to understand and get some interpretability of it. In our model, we define only one main emotion per one text, and also we kind of do not take into account that we can have no emotion and neutral emotions towards a certain text, but in that manner, we are trying to implement it and be reflected in a trigger level. For example, you can still, if you think there is some neutrality, you can try to reflect this emotion with some particular class of the emotion, but with a really low level. As for domain selection, we went for Moldova. Moldova is one of the countries that's holding election this year, and in October they'll be voting for the joining the EU. Also, its strategic location is quite important, and its proximity to Russia-Ukraine war can possess threats to Moldova itself. Also, it hosts Transnistria already, which is de facto state that has major Russian influence and potentially malign actors' influence there. And finally, we decided to go for Telegram channels, and Telegram has gained a lot of popularity in Moldova in the last 2 years with a lot of news sources and source of information actually present there. Yeah, and as I mentioned, so we used the proprietary demographical research conducted in Moldova. It was based on demographical factors and answered to simple questions like about the views and political and personal. And for that, we chose 2 clusters of people. So in any case, this framework would work for other clusters, but we decided to do additional comparison between the emotional triggers of 2 non-similar clusters. We took the pro-EU and against EU members, radical ones. And we used GPT-4 to generate the storyline for representative personas from these clusters, and we would refer to it as persona context. And here you can see these 2 stories or indices for 2 personas that was generated. So in a related work, we identified that there were 4 main categories which were related to this work. Less emotion classification of the text, which was based on the just emotion classes and was different in terms of how many emotions that it was analyzed by. But emotion cause extraction field was more interesting because it was focusing on identifying the actual parts of the text that were triggering the specific emotions. And for that, for example, Jean and others in 2023, they have used already the LLM in order to jointly predict the emotion and summarize the triggers using BERT. Also, an emotion is a powerful tool for using it for manipulation detections. There were many works that used the emotional features for fake news detection and classification. And also, for example, Lussery, Bonyard and Ferrara and Baumik and others, they used LLMs already to analyze influence campaigns on Twitter previously. As for LLM impersonation, there were also some conflicting results in terms of how this personas context is improving the results of LLM inference. Jan Pei and Jurgens, in their work, they actually show that the role incorporation improves the results for the defined tasks, while the more recent paper from Cambridge, they actually tried to quantitatively define how it improves, but report that for tasks like toxic content and irony detection, the persona prompting introduced modest and inconsistent improvement. But nevertheless, so for dataset collection, we collected a dataset and it was based on the list of sources of Moldovan Telegram channels. It was defined by less data analysts, and actually these sources were already known to have some neutral or manipulative content in their history. Also, these publications were collected using the less data and accessed via the API. The range for the publications was chosen from 13th March to 13th of April. It was 1 month. And there were also additional steps taken in order to filter this information, in order to select the best data set, and also like select the best publications that can be used for labeling. So we removed the empty text, we removed the text that actually were based, that were too short, and also removed the text that were too short to understand because they consisted the video or images that you need to understand. And after additional sampling, so in the end, we had a relatively small set of publications, which is 236, but it was across 68 channels, and it was both in Romanian and Russian languages. As for annotation, we had help from a Moldovan organization, Watchdog MD. They helped us to organize this annotation process, and they gave us the people who were from the same demographical cluster that we selected, and we asked them to annotate this data set that we selected in order to identify 5 main questions that actually aligned with our analysis model. And also added one additional option for undefined emotion, because we believe that there is still some edge cases where it's hard to understand which emotion is being elicited. But what's more interesting is that most of the emotions that were triggered by that data set were negative and with anger prevailing emotion. And the general agreement between the annotators was very low. So this also supports the evidence that there should be a different approach for representing several emotions elicited from the text, because all people are different groups are triggered by different things. So in terms of trigger phrases, there was also like very small overlap in terms of what happened. One of the limitations that was identified at this point is that the length of the highlighted spans for trigger spans was very different for annotators. One annotator on average selected 28, another to 40 characters. And we believe this also influenced the future results, but at this point we proceed without any additional steps. Also, we did train evaluation split. So in this case, because we were working with LLMs, which require relatively small amount of data for fine-tuning and for few short inference, we did 30-70 train evaluation split of the dataset. So we wanted to get as much as possible information for the evaluation. That's why the training data set in this case is that small, but it follows the recommendation for general for these models. And also, when we were splitting this data, we took into account the date, so we didn't want the news to be intersected between each other. So we're gonna get some information about training and evaluation. That's why we took into account the date. And this is how the example of the data set and actually the inference look like. So it was in a JSON-like format. It consisted all of the components that we described. And yeah, that's what we proceed with. As for the experiments, so we used no context version of the prediction as a baseline. So this is a general prediction with AI prompt definition. It doesn't contain any persona context that we generated previously. Zero-shot learning uses these persona contexts in its prompt. Few-shot learning includes also 5 and 10 examples. Separately, we tested 5 and 10. For fine-tuning, we did fine-tuning with 50 training and 20 evaluation examples in order to choose the best fine-tuned checkpoint. And for our LLM candidate, we chose GPT-3 Turbo that was at that point available for fine-tuning with the official OpenAI API. It was also, there is also a model that is optimized for JSON, which was also good for our task. And also, in general, it was cheap in terms of data and money for running the inference for all of these approaches. As for evaluation metrics, so because we have a multi-class manner of our values, we use the weighted versions for recall precision F1 score. And as for trigger spans, we used two forms of similar scores, which include also recall precision and F1 score, but in strict, which matches the actual strict match of textual spans, and the proportional, which measures the overlap between annotated and predicted trigger spans. So, and here are the results. So as you can see, the fine-tuned approach has shown the best results comparing to the baseline with no context. I also need to say that inference was run for 3 random seeds and was averaged for 3 random seeds. So we understand that there are no hallucinations and the results are kind of stable. And yeah, and also it was averaged across 2 personas, so it was for average across 2. Also, we can see that the failure rate in general was much lower for fine-tune, which makes sense because it learned to the how the format should look like, and the failure in this case we define as a corrupted JSON or the values that are out of our ranges and so on. But taking into account all of these facts, also there's some evaluation to the results. So at the moment, F1 score was selected as the main evaluation metric, but for some business cases, the precision might be more relevant as calling somebody using emotional triggers might be a high risk for the reputation. So you should take into account. And in previous results, you can see that if you look at the precision, the 5 short learning with 5 examples actually was more precise. Also, the weighted F1 score was used, which waits for the imbalance in the classes, but in this case, we also waited for the undefined class, which was kind of also added as a like additional case, but in this case, it's also evaluated against this class. Also, there was very poor performance across the trigger phrases for the strict version, and there's also explanation why, so we had in the data this great difference in terms of the length of the spans. So this can be explained why this trigger phrases generation was quite poor as well. Also, trigger level was in general evaluated as a class, but it can have a more value. It can be treated more as a value, so a different method for evaluation can be used. And in this case, again, we had only one annotator for one demographical class, which is kind of, again, one person represents all of that. So it would be better to have, again, some agreement and several annotations for such emotional triggers. As a final of this research, so we actually propose an active learning system that can be used for emotional triggers detection in our particular case. And we actually took all of the steps defined by this model, but with the last step, which includes the actual inference for continuous data for a certain period that we can use for analysis of emotional triggers that particular channels are using, and also to, in future research, to add some additional steps on inference analysis and possible intervention that can be done to these particular cases of emotional triggers usage. Okay, and so to conclude, we can see that incorporating a persona's context has improved the results of emotional triggers prediction in our case, comparing to the baseline of no usage of persona's context. And also fine-tuning showed the best F1 score across all variables of the defined analysis model for emotional triggers. In the future work, of course, we want to extend the data set, extend the number of publications because it's very small, we understand that, and increase the number of annotators because, again, we have one person representing one demographical clusters, and to get greater labels, it will be better to have at least several and to measure the agreement. Also, in this case, we selected two clusters to compare, which are kind of more pro-radical, and it makes sense in the future research also to consider somebody more in the middle who was deciding on the vote, and because usually influence campaigns are triggering, want to influence these people much more than those who are radical, of course. Also, we didn't do any additional more knowledge evaluation of the LLM of GPT of what it knows about Moldova, and it requires also the analysis of the description that it's generating. This is additional step. Probably other techniques like RAG can be used in order to improve this knowledge. Next step is multimodality. I mentioned that we filtered out the text that consisted only video or images, but this is not how the online content is working. There's a lot of content like that. And finally, we want to extend and test this approach for other domains and countries. So in this case, we took Moldova, but there are more countries that are going to have elections or can be manipulated. And finally, I want to thank Grammarly for giving me the scholarship to study in the UCU. That's why I'm get happy. I want to thank Let's Data for supporting me and giving me a possibility to make change and to work on very interesting tasks. And I want to thank to Watchdog MD for helping me to implement this and to find the people who annotate this data. Thanks a lot. I'm very happy to answer your questions.
Anyone would like to start? Okay, I will start. Thank you for the presentation, Anastasia. Have a couple of questions. It seems to me that using like AI generated personalized data is fine, but are you going to inference your models on a real personalized data? Is it law allowed?
No, so we're using the demographical research for that in order to generate the personas. We're not using personal data. So in that case, we are not using any personal data. We're using some aggregations based on the research that was previously done and the facts that are stated there.
Then slide 17, please. So it seems to me that so the approaches is you've chosen it are pretty straightforward, like go to solution, off the shelf solutions. For you take any existing model, you can do like zero shot or few shot and or fine tuning and um, maybe I missed that. So what models? Why you fine tuning? And maybe you can provide a little bit more grounding why this solution, and maybe ground also in existing work what other approaches we're using, if they exist.
Yes, on this work, we went for GPT-3 Turbo for all of the solutions. So because we wanted to compare different approaches like few shot and fine tuning, for example. So we went for this choice, and we find because GPT-3 also requires a relatively small amount of data to fine tune, and it's actually working well with the like few short examples. That's why we went for it. In the previous research for influence campaigns, there were used Llama and Roberta, uh, mm, and they were also using the similar techniques, but they were not taking into account this. So they were using it for detection of influence campaigns, if influence campaign is present or not. And they were, yeah, so that's basic prompting that they were doing. So it's kind of a similar task, but it's not emotional triggers detection.
Okay. I'm also curious about results analysis. For example, you have some metrics and you show us the tables. Have you performed any further result analysis? For example, what are the failing cases? I mean, not quantitative, but qualitative.
Yeah, in terms of it was done manually. First of all, I also did some analysis on the descriptions that were generated, also manually assessed, and I give some examples of how it was generated. And actually, for fine-tuned model, it was also the best results in terms of how descriptions differ between each other. But in terms of the deep analysis, additional analysis, we haven't done that yet. Uh, because for first reason, we want to get like the more and better data in terms of the triggers that we collect, because it's very unclear how to analyze the undefined emotion that one person would um, assign to a specific test.
Yes,
Data set.
and as you also mentioned, many times, I guess the company you are working for, and I would be like grateful if you could outline specific your contribution to like to this research. You mentioned you used a lot of annotation works, annotators, and so like what part of research you did yourself?
Yeah, so I used the technology of my company for the forming the list of the Moldovan Telegram channels and for collecting the data. That's it. So all other works in terms of the analysis model formulation and the test and fine tuning, it was done by me.
Thank you. Uh,
Okay, thank you for your presentation. I have a couple of questions. So, uh, can you go back to the slide where you do train test split? Okay, so you have mentioned that you have split it by date. Does it mean that you have like put some previous data like for the training and like future data for the?
Yes.
Yeah, I'm also just a bit curious about channel intersection, because just this time splitting is completely good idea. But for example, if you have like messages from the same channel in train and test, that may be a kind of leak, because you know, at least even some hashtags with channel names can be the same, and the model can overfit to this possibly.
Yeah, good point. Actually, the good point about the channel names. But actually, in the annotation process, several annotators identify these ads and reference to the channels as a trigger because they have some knowledge about those. Um, yeah, so in our case, we wanted to analyze the content and the channel. That's why we didn't do it by channel, but I think it's a good idea, yeah, to do some additional pre-processing.
Okay, and um, yeah, also it seems that if we go to the results section with metrics, it seems that some of your results, for example, precision for emotion FCL5 has pretty high standard deviation, and I think that there are also like same issue with trigger level FCL5, which is also has a pretty high standard deviation, and yeah, and this score might not be the best considering such high standard deviation levels.
Okay, yeah. I highlighted by the average score, and if the average score was different than the same, then I was selecting by standard deviation, but also good point.
And yeah, and I have also seen like the review, and one of the questions was regarding the choice of the metric, and it seems like if you, at least for emotion class, as I remember, it's like binary classification, because we have two classes, as I remember, like positive,
So
negative.
in the end, it was a multi-class classification because there were some cases for undefined emotion.
Okay, but anyway, did you think just to consider some soft metrics, let's say like Rockoak, that take into input like some like soft labels rather than hard one?
Um, yeah, so initially we didn't think about that. So we decided to go for the standard precision recall F1 score. We didn't take into account the accuracy. But yeah, I agree with the reviewer that it can be taken into account.
Okay. Okay, yeah, I think that's pretty much it. Thank you.
Thank you.
Thank you, Anastasia. Can you get back to this diagram when you describe this case of Moldova with those different malign actors? Yes, this one.
It's a target.
This is a target.
Yeah. So this is from EAC report. They analyzed the random sample of 100 incidents from 2022, and they were actually identifying that like government of Moldova, Maya Sandu, and Moldova itself, they were the targets
So
of
what we see
influence
here, how
influence.
to interpret this diagram that you, so it's not from those Telegram channels you analyzed. It's
No, no.
just
It's just like they reported that
this
Moldova is the
report
target. Yeah.
about Moldova.
No, it's about all the incidents like analyzed in 2022. The sample of from all the incidents analyzed 2022.
But what
But it's not mine.
what channels? I mean, so what media?
I think they analyzed several channels. They included Telegram, Twitter, news. I think so. It was multi-domain.
So it was like across the Europe or
Yes, it's across the
oh,
Europe.
okay. So then I misunderstand. And then can you please reiterate about this trigger level that your annotators define? So how you actually define the trigger level and how you calculate it for your annotator?
So this is a subjective intensity of how great is the emotional trigger from this emotion. So, for example, the task defines that you read you read the publication, and then you identify and analyze which emotion is elicited from this publication. And then to this emotion, you are given certain characteristics like the emotion class, the trigger level, which again subjective, and trigger phrases and some explanation of why is it. Why?
Can
What
you
is the
provide an
motivation?
example of instruction for annotator, how she or he should um, select this trigger level?
They should select themselves.
Yeah, but there should be some examples or whatever. Anything you have?
No, just from range to 1 to 5.
Uh,
I don't.
how many annotators did you have?
2.
Um, two for whole set of the channels, right?
Yeah. So it's 236 publications in the end, and 2 annotators annotated them. So it's 2 annotators for 1 publication.
And then what was the difference between trigger levels of those two annotators?
So for negative emotion, it was kind of normally distributed across the 3, the value of 3. And just for the positive, for the first annotator, it was much less positive emotions in the defined content.
But for me, it seems like from cognitive perspective that this kind of we are really for humans. So like from if we take some knowledge from the domain of psychology, cognitive behavior, that it's quite hard to treat those numerical values, and it's really depend on our general state of mind, state of psyche at this moment. And I see that, for instance, for your two annotators, in terms of positive, she could be in a more bad mood at that moment and decide do not like pick the positive or less positive. And in terms negative, okay, I will put three. Just I don't know. Let's put three. I mean, how um, this number or this trigger level it's influenced by all this let's say outside outsider information, outsider domain, let's say environment. Better to say.
Yes, it's very subjective. It depends highly on the person. That's why we see that there is a need to collect this information for several annotators for from same demographical cluster in order to understand what can be the average between them. But in general, so our idea here was, for example, in future steps, to identify those and analyze those triggers which are of the highest. So a person subject has subjectivity to rate this particular trigger as 4 or 5, and after that you can analyze and understand which kind of narratives or which kind of messages are being promoted in this specific publication, and there might be something interesting that this particular malign actor is manipulating with. So that's kind of one way of how you can filter out these triggers and to identify with those with the highest intensity in terms of triggering the negative emotions, for example.
And I want to elaborate on the question from Ruslan about your contribution. So you mentioned that you use like services of Let's Data to gather channels and gather data. And what about annotators?
The annotators, so the organization, which was also found by Let's Data, but it's a Moldovan organization that we collaborated
This one,
with. Yes.
watchdog.md, okay.
Yeah. And they helped us to find the annotators for these demographical clusters.
And have you communicate with those annotators?
No,
So you just
I opened the label box.
so you initiate the process and then you receive the annotated data.
Yes, yes, we received and collected the data.
And uh, who did write the instructions for annotators?
I did.
Uh, okay, and how do you satisfied with annotators' work?
Um, I'm very happy that they spent 5 hours of their
Yeah,
time to
yeah. I
annotating this
mean,
data.
you appreciate their help, but in terms of the quality of their work.
I was quite satisfied because it complied with my hypothesis that this content is going to generate a lot of negative emotions and emotions of anger, because I was going through this content as well. And also was interesting to see that there's actually the difference in the annotators results. So basically it also supports the hypothesis that you can't kind of make a model that's going to predict the emotional triggers for all, and they are very different. But then in that manner, there was also like I added the visualizations of emotional triggers that they actually highlighted. It was very interesting to see, like, for example, there was a certain pattern that one person was labeling the data related to America, for example, I don't know, to Yugoslavia, to NATO. So these were the triggers, and another one was appealing more to my son and so on. So there was also a difference in terms of what they highlighted. So for me, it was very interesting experience in terms of knowing more about Moldova and what people actually think about different points and different topics, and I think I'm satisfied. The one thing I'm not satisfied is the length of the trigger spans, but I think it's kind of a hard task to define in terms of selecting what is triggering you.
Yeah, I just want to comment on this that that's a crucial part of the whole pipeline, because if you will have weak data, then obviously even having perfect algorithms, it would be hard to get good results. So that is why we spend so much time on preparation for data. Thank you.
Yes, thank you.
Just to elaborate on what Alexei has already said, uh, uh, I would share my interpretation of this stuff in the context, and would ask you to please correct me if I'm mistaken. So as far as the number of annotators was just 2, and their judgments were emotionally and personally biased, the hidden intention of this work was to teach your solution to just mimic the annotator's behavior while they're labeling the data. Is this correct in your interpretation?
It's to mimic their reaction to the publications after they read
To
it.
mimic the behavior of the annotators when they classified the training data.
Yes, I would say yes.
We're happy about the degree of this mimics. Was the deviation in the behavior of the solution and the annotators different a lot, a bit? Did you analyze the results in this aspect?
No, we didn't analyze it in that aspect.
One more thing, just to as a suggestion, just imagine you have several groups by two, say four, with the different emotional states coming from different origins, like two from the US, two from, I don't know, from Manila, two from Moldova, and two from France. Definitely the labelings will be different. It would be great to check the solutions induced by those four groups and to compare the solutions.
Yeah.
If they all will definitely well mimic the behaviors of those four groups, then you may indirectly judge that you are able to teach the solution to behave in a proper way.
Interesting.
Thank
Yeah.
you.
Yeah, and also one comment to that. That's why we actually went for Moldova. In this case, we didn't want to focus on Ukraine because there are a lot of great studies about Ukraine, and it was interesting to know another domain and to explore their emotional triggers and how they react to the news.
Okay, the question is, do you think Telegram is really representative in context of Moldova? Do you have any proof for it?
Yeah, so it was one of the reviewers' comments, and actually in SimilarWeb reported that Telegram became top one mobile app in the recent 2 years. It changed from WhatsApp recently, so there are quite a
Okay.
lot of channels there.
Okay, and the same question to elaborate previous questions. It's a very sensitive topic, so is there this ideal for annotator exist? What if annotators is just uh, wrong or biased? So how can you? The same question you can not answer. So,
No, I think like
but very
it's very important to know these biases. So, for example, if a specific demographical group of Moldova is biased and wrong towards specific topic, you need to work with this group and to promote like critical thinking and to awareness of a specific topic. So that's kind of if they're triggered by a topic that is promoted by malign channels, that's why there is a need to do something with that, I guess.
it seems to me you didn't get the question. What if all annotators are biased in the same way, and you just don't understand this fact? Because all annotators involved in the work all are biased in the same direction.
Okay, then the
But
model will be biased.
so yes, you will just let me say approximate their behavior and habits, but not the ground truth. And
But
is this ground truth exist at all?
yeah, it's I think it's somewhere in the middle. So it's also
Why
biased.
we asking this all the same question, because the topic is extremely sensitive. Yes.
Yeah, I understand.
So it yes. Thank you.
Okay. Thank you, Anastasia.
Thank you.
The next student will be Alexander Kornienko, and he will be presenting his work enhancing large language models capabilities in grammatical error correction task. and Alexander was advised by Konstantin Omelyanchuk.
Hello, dear committee, dear guests, colleagues. Happy being here and presenting the results of my master thesis research regarding the improving the grammatical error correction with large language models. And the structure of the thesis presented here. So we just briefly describe the motivation. I will describe the research gaps, approach to solution. After I'll present the experimental results and finally made the conclusions. Recent years, the development of the conversational agents has a significant attention in the field of the natural language processing field. Especially to build such systems, the large language models is often used because they are highly capable to perform different kind of tasks, starting from the question answering and even a coding. And the key benefit here is that it can generate text with a human level quality. When it comes to the grammatical error correction ability of the large language models, it appears that many individuals use such models for text composing. This includes not only the text generation, but also text refinement and revision. That includes to fix the different grammatical issues as well, to generate highly high qualitative texts, meaning fluent and still grammatically correct. Nevertheless, we provide the research gaps of this field of building such writing assistants with using the large language models. And we found the only 2 papers that investigated the grammatical error correction with using large language models, but they are related to the proprietary models. And this was done for the zero-shot learning setting, meaning no any weights updates requirement. So the model is capable to perform this task out of the box. At the same time, the only Llama 2 model on the Llama model was used to perform the GC task, but still in the supervised fine-tuning setting. Where other models, other open source language models are out of the researchers' attentions, making this field of use open source models underexplored. At the same time, we didn't find any of the researchers that apply the alignment techniques, allowing not only improve the quality of the large language model to perform the GC better, but even to improve the quality of the generated text in terms of grammatical correctness. Having this list of the gaps, we formulated the hypothesis. The first, our hypothesis is that the open source models are pretty capable to perform the GSC out of the box and is on par with the proprietary one. The second on our hypothesis is that to suppress the current state of the art, the fine-tuning is still required. And regarding the last hypothesis, we believe that applying the reinforcement learning with human feedback can improve the ability of the models to perform, to generate grammatically correct text. And here we are going to align the GC, the built model with the GC benchmarks. To cover approach to solution, we first would like to discuss the data sets and the metrics. We choose the English language as the primary language of this research, and here we choose only 3 out of others data sets. Here the CLang, known as the largest data set in the field of GC, and it consists from both the manually created data, but also with the synthetic one. 2 others, the knuckle and V and iLockness, are much smaller, but still they use not only for training, but still for the model benchmarking, allowing other researchers to evaluate the open source developed system with the open source systems available in the field. To evaluate system, we use the we use two quality metrics. The max match is M2 metric, and another one is errand. We choose these two metrics because they have the highest correlation with human level judgment, and they are reference based. That meaning, so this model takes the hypothetical edit that made by the model and compare it with the human reference, and after calculate the if f 0.5 score incorporation, the precision and recall in the formula. These two metrics are joined with the benchmarks, the CoinNL 2019 and BN 2019. So it also what I mentioned previously, the knuckle and VNI lockness, and reported in this benchmark. So we will be able to understand the quality of our systems. From the list of all available language models, we choose the models of the same size and quality on open academic benchmarks, because we would like to, because these models are pretty known. Sorry. This model doesn't require any specific hardware to serve and use it in the real world applications. At the same time, with a reasonable cost, we can solve different real world applications. The first, in our work, we are planning to discuss the quality of the match, the capability of the model in zero-shot setting, meaning so no weights required, and we just can vary and experiment with task formulation. Here we choose the three models and investigate the dependency of the quality of the model on some specific prompts. It's a formulation of the task presented on the right of the slide. Depending on the architecture and the model sizes. Our next set of experiments, in our next set of experiments, we explore the fine-tuning setting and define the configuration that allow us to beat the state of the art in the field. And here a list of different properties, hyperparameters to vary and to find the best that fits our goals. So we are going to experiment first with Llama and then apply these techniques to the Mistral and GIMA model. Also, we are going to vary the data set and their combination to find the ones that allowing us to get the best results. Model sizes, type of the pre-training, meaning so some models, large language models, developed in two modes. One is as a original language model, but another one is fine-tuned to use as in a writing assistant mode, in a chat mode. And also we are going to experiment and find the trade-off between the fine-tuning setup. Here we are seeing so updating the full model, but also updating with parameter efficient tuning to update only the some part of the model. And yes, our goal is to achieve state of the art. In our following experiment, we will use Llama 2 model, so already that we've got from the previous hypothesis, and we are trying to align it with the preference data, allowing us to improve its quality on the chosen benchmarks. Here, our objective of this hypothesis will be how to create the preference data set, because in this set of experiments, it has the highest it is highly important. As fine-tuning, to fine-tune this model and to align it, we use a direct preference optimization technique because it doesn't require the reward training model. This reduce the computational costs. At the same time, authors recommended to use it because it has a better coverage in this task. And yeah, our objective of this part of the research is to select the way of preference data generation and also and also provide some recommendations. Our solutions starts. So we are starting from the zero-shot setting. Here, we are decided to use the grid generation mode because we would like to provide the reproducible results. So here mean the beam size of 1 and the lowest temperature. At the same time, we are going to use only hard prompt tuning. So meaning, so we just manually adapt and change the prompt according to the matrix. At the same time, so we are going to use the prompt of the prompt of special structure, where in the first sentence we enable we condition model to perform as a writing assistant. Without this system prompt, so model doesn't generate reasonable outputs, and so we had different complexities with parsing the outputs. Also, to enable model generate output with convenient for post-processing format, we we condition model to generate only the output sentence. Our experiments shows that the specific error, that the mention of the specific error type, especially the punctuation, can change the precision recall balance, and that result in deviation in 1% in the scores. At the same time, only getting the punctuation in this prompt, we are achieving the best results in this set of experiments according to our benchmarks. Here it's on the CoNNL, and on the BIA we had a high scores. On our other set of experiments, we also we followed the recommendation from the proprietary model investigation, and we tried to incorporate the positive information in the prompt. Here we are introduced the level of the learner, language learner, and also a number of mistakes needed to fix it. And we see so with these two parts of the prompt, we can also change the behavior of the model that reflects on the precision and recall. And finally, we see that the model perform on the scores better with having in the prompt advanced learner, and we are asked we condition model to fix only a few mistakes. Also, researchers who investigated the proprietary models noted that the large language models tend to overcorrection, because in case if there is some error, it tries to rephrase or change the part of the sentence, but not the follow the minimum the way of fixing the specific error only with the minimal required edits. That meaning and that led to having the pretty high recall on some benchmarks, but lower precision. In this set of experiments, we added to our prompt the do not rephrase. That meaning, so we condition model so that to do not allow it to rephrase the input sentence, and that lead to significant improvement in terms of our precision recall balance. And here we see that for the six prompt, we see the highest scores on both data sets. Then we evaluated other open source language models on the same benchmarks with the same prompts. And we see here that Mistral model has the highest recall over all of our experiments we got in this series on this master thesis. At the same time, this is correct only for the CoinNL, but not applicable for BIA data set. But still, if you are going to analyze the results from the chat llama model, we see it is very similar or even outperforms the chat GPT of version 3.5 from the research we've got from the field. That means so this model is pretty capable of performing this type of tasks, but still but still has pretty low scores on another benchmark. On our next set of experiments, we used the full supervised tuning, meaning so we just updated all weights. It's 7 billion of the weights of the model, and trying to vary in this set of experiments the data set. We do not see any dominated any setup of combination of the data set that is predominant across all benchmarks. But interesting point here is that the V and I data set is pretty qualitative because it provides the highest recall on the CoinNL and also on a BIA. In the setting of one where we just use only one data set for training. That also meaning we just used only 35K of thousand of the samples to train this model. In this and following set of experiments, we vary hyperparameters, and here report the best. We also varied in the following set of experiments. We also varied the size of the model and the way how it performed and how we can condition it to generate and to fix the grammatical errors. And here we see that stable performance, improved performance for larger model. So that means so we just having the larger model, we can simply improve the score. But also there is another observation that also confirms the observation from other researchers that using the chat version of the models and prepend to the prompt the request to fix the grammatical errors also contributes to its quality. Our next set of experiments we use in this set of experiments I describe it. We use the full supervised tuning, but still we try to optimize the cost of training and try the parameter efficient tuning, meaning so we are able with this approach to adapt only a specific weights of the transformer blocks. At the same time, we also introduced we used the low rank adaptation algorithms that allowing also to reduce number of the trained costs because of we are updating its low rank representation components. And here we see with this set of with this approach, we can speed up of training process in 30 times. After experiments with different combination of this model fine-tuning, we found that more weights we update, the better scores we have. But still, in this set of experiments, the Mistral model outperforms others, not considering into account the full fine-tuning. Having the strong reference model, I mean, so the model we've got on in the supervised fine tuning, we tried to align it with a preference data set, and here we use a direct preference optimization technique that requires the input prompt and also pair of the outputs of the model. One is the chosen, that meaning it contains the preferable edits, and rejected that contains, for example, some errors not fixed by the model or phrases, etc. And the idea of DPO is to fine-tune the fine-tuned model, but also we can control the deviation of this model from the reference, meaning so how far from the reference model we can change the fine-tuned one, and this parameter can vary with the beta parameter. To The open question in this set of experiments is how to create the preference data set that contains the information which of the edits is preferable, which one not. And here we choose to, and here it's there are several things to mention. The first is how we can get more than one output, because in the previous experiments we use a greedy search. That meaning so we just generate only one output. And in this way, in this set of experiment, we enabled the sampling mode and generate with the same model different several outputs. In our experiments is 5, and they can a little bit change one from another. And having this set, then we score it. We score them with some scoring function and choose the as a chosen one the hypothesis that has high score, and as a rejected some hypotheses from the rest. In a greedy mode, we use the last with a smaller score, and but still in this slide we see two methods that we consider to use as a scoring function. The first is the Greco quality estimation. This method commonly used to score the outputs in the ensemble and find the best. This method is pretty interesting because it sets the global state of the art in the field of GEC. And it considers into account the input and output and scores each of the edit in the hypothesis, and after it forms the final score. The final score. Another method is a Scribandi score that is referenceless metric, and it takes into account under the hood the perplexity of the source and of the output. And having this, it just choose if perplexity improves, it considers that that this sentence has improved score, has improved the GSE. And we vary in this set of experiments the beta parameter, and we found that the Greco score contributes on all our experiments and outperforms the Scribandi score, and getting the maximum in the beta equals to 1. Surprisingly to us, with increasing the beta, meaning so we just fine-tune more model on these data sets, the score going down. And in this set of experiments, we try to vary different combination of the outputs of the preference data set, how it was tuned, but resulting in this table, so we do not see any significant improvement with using this method. That means so we need to continue work on this method, just trying to adapt it, and it will be done in the future work. Coming back to conclusions, we showed that the open source models are pretty capable to perform the GC, and they are on par with the proprietary one. And we also showed that to beat or be very close to the state of the art, we need to perform full supervised tuning technique, and the preference tuning doesn't show us any of the improvement of this field, any of the improvement of the GC model we used in this research. Regarding the limitations, so we have a couple of them. The first is that we are oriented only on the English language. That meaning so we need to prove our hypothesis on other languages. Also, we used only the manual only the automatic scoring, and that doesn't allow us to score any very specific edits that could be really scored as a positive change, but still. So, and here we would like to use the manual evaluation, and also we stopped using. We used only several models of the limited sizes, and the models of the big size are out of the scope of this research. And also we used in this to generate the preference tuning preference data set. We used the automatic scorer um, trained specifically to beat the state of the art on the benchmarks. And this is a bias we introduced in this kind of experiments. But still, it was shown that even with using this method, it is not clear how to improve the score of the model. And yes, and the last but not least is that we used only the greedy generation, but large language models mostly used in the sampling mode. That means so we need to incorporate additionally investigate this in the future work. Yeah, thank you.
Anybody would like to start?
Thank you for presentation. It was very insightful for me. So the first question is regarding zero-shot approach. I've seen that you had a lot of different prompts. What was the methodology behind generating such a prompt? So was it manual? Was it like prompt engineering for prompt engineering? Could you please give more details?
It was fully done by hands without applying any of the any of the current approaches like automatic prompt optimization. We just having one prompt, trying to add or delete some of the part of it. For example, the type of error. We're trying to find the one that contributes or not contributes to the final scores.
Okay. Next question is regarding sampling. So you've said that you used almost zero temperature for generation.
Yes.
And yeah, as we know, with zero temperature, the results are usually well, as how to say it, yeah, they are less variable with low diversity. So what does your intuition says if we will use higher temperature? Yeah, we lose reproducibility, but will the results be better in terms of average metrics?
Yes, I cannot agree or disagree with this. I think yes, that's one of the things that was out of the scope of this research because we tried to because of cost saving and time constraints, we decided to use only the greedy generation. That shows only one of the point on only some estimation of the model quality. But for sure, with adding this randomness in the in model output could, and I believe it significantly contributes to the recall of the model, but still we need to investigate it more, and it will be done in the future work.
Yeah, and the last question, how many computational time did you spend for all of these experiments?
I do not count really, but it was significant, I would say. So one experiment
50
takes
days or
one experiment takes dependent on the level sets. For the knuckle it's 1 hour, something like this, but for the BIA it's 4 hours. So to get only one of the line of this experiment, and so we had a lot of different experiments depending on different size. And I do not count here the full supervised tuning, that is very expensive stuff.
okay, thank you.
Thank you very much. Uh, Thank you very much for your presentation. I was thinking that can you please explain why did you choose to use zero shot? Because I think it will be interesting to see the results of the few shot as well.
Thank you. That's a good question. So I investigated the paper that describes that investigates the few short learning for the ChatGPT, and it's shown the modest improvements in 2%, something like this. And it in this case of experiments, they used 16 samples to show the model how to perform. Why we rejected to use this method? Because first of all, it's expensive, and but maybe the more thing is that we this kind of the technique very dependent on the examples we used in this prompt, and this to find the best, we need to solve this combinatorial problem and find the one. And it will be very adapted to the benchmarks. But here we try to understand the general level, how model can perform on simple zero-shot setting.
Okay, thank you. Makes sense.
Thank you, Alexandra. Can you get back to the slide with when you compare those different prompts and results of using different prompts? Like anyone? Oh, yes, that's a good one. So it's interesting. It's very interesting for me. Like I'm sitting on a whole master thesis defense from the very beginning of this program, and we already have like more than 100 of them. And it's very interesting for this year that we have several theses on LLMs. And now for us as researchers and engineers, probably mostly for as researchers, we have a new tool. Like what we previously we trained our own models. Obviously now we cannot do this because of their size, so we fine tune. Or like in your case here, we try to play with different prompts. And now prompt is one of our like tool. Like
Yes.
one of the in the whole toolkit. So you designed several prompts specifically, and you know that prompt engineering is part of kind of magic stuff. So you pick those like five on this slide. And my question here is, how do you estimate or what do you think about that? Probably there is somewhere in the cloud, there is a perfect prompt for this task. So how to be sure that you didn't miss it?
That's a very
Even could increase the result.
Yeah, that's a very good question. So I think if we will be very intensive in this work, so we will be able to achieve the state of the art by tuning the prompt only without any fine tuning. Here I'm trying, being as a human, I'm trying to formulate the prompts as I as a human can solve this task. How can I explain to solve this task to others? So meaning some, giving this tool some objectiveness. But here it's something that I can explain and even say that they're pretty good, but still they show that with even with this approach we are able to get some results that can solve this task.
Yes, definitely. This is why I'm asking, because so how did you pick those prompts? They were like you just write them as a human being, or you get some paper where there was like similar prompts?
Some of the prompts, like this one, I reused from the proprietary models. Some of the prompts I tried to get where I just think how can I make this prompt much clearer to the to condition model to perform some task. But this one I tried to understand how the other researchers also formulate these prompts and try to enable my imagination and try to vary the formulation. So that's
So
it.
on the another parallel defense during the bachelor thesis defense, they find out that one of the thesis was written with the help of the ChatGPT because of the using of some keywords like delve verb. And I'm curious that if we will, with the same all the processes, but instead of Alexander from Ukraine, there will be guy from Nigeria, and he will generate prompts from his cultural linguistic background, and we will get probably other results.
Right.
I mean that is part of the. There are too many variables in this kind of scientific endeavor.
Yes, so maybe I can add here one of the future works that we are working right now is to introducing the automatic prompt optimization that is able to adapt model and adapt the prompt to some specific task. So and it will be interesting to I would recommend you to read it. It is really funny. Yeah, that's.
Okay. What is the feedback from Chernodub is Krużanski?
They're pretty impressed with numbers. We wrote the paper, and they are flying right now to the BIA 2024 to present some of the results from this research. So we did pretty. So this is only the part of the research, but we also in this paper use the ensembles of the LLMs. So the paper is existing the free right now, and yeah, so it even that paper set the state of the art in the field. But now, so in this paper, I only showed, so it is very close to state of the art.
Have they implemented this in Grammarly?
Good question. Yes, we investigate and we can use large language models to solve the GEC.
You are working in Grammarly, yeah?
Yes,
Ah, I see. I see.
we are colleagues.
I see. Okay, why F 0.5, not 0.1, not 0.7?
This is because the researchers from this paper, I do not really remember the name. It's Napolis in 2019. He probably
Going
he
in the wrong direction.
Yeah, so did investigation on different metrics and found that especially F0.5, that is precision oriented, is highly correlated with the human judgment. So they and that's why we are starting using the F0.5. That's only the explanation.
I see. It's interesting why they decided so. Okay,
Yeah.
thank you.
No more questions. Thank you, Alexander.
Thank you.
Now 8 minutes break. Oh, sorry. Minus 2 minutes. Sorry, I miscalculated. Um, so the next presentation will be delivered by Nazary Drushchak, and he will be presenting his thesis entitled Stereotypes in Large Language Models, Demographic Biases in Hiring Decisions. And he was advised by Mariana Romaneshin. Nazary, the stage is yours.
Hello, everyone. Yeah, I want to it's my thesis, and before I start, I also want to thank my advisor, Mariana Romaneshin. Also, thanks to Applied Science faculty of UCU for giving me the scholarships and giving the computational resources for this research, and also special thanks for the Genie team, which provided me the data, which I will tell a bit later about that. So my plan for today is telling some motivations and background related works and research questions and gaps we'll be finding, some our solutions, data sets, results, and some conclusions. So, what's the motivations? As we all know, and we have a lot of also research today related to the LLMs that we try to put these LLMs in different part of our life. And sometimes we forgot about this responsibility, about privacy and that. And for example, one of the case can be this with a lawyer which generated fake ChatGPT cases, and anyone do not check it. Or another case when we use it that uh, in USA. Will try to use to like evaluate 75% of works by GPT. They started it from this year, and I believe they will use it and try to do it in a proper way to analyzing the fairness. And if we will jump into the hiring, we can find the most famous example related to the Amazon and their recruitment tool, which when they train and use it, they find it that this system against women. And after that, when they try to analyze, they finding that it's a problem with their data, and they lose a lot of cost because they need to close this program, and only after a couple of years they return to them. And also that now it's not only the good stuff to have our system responsible, but it's our some requirements. And one of the examples that we have is AI hiring law, which created in New York. The idea that you need to provide why you when you use this hiring tool, you need to provide like explain why the model generated it, and it will be really easy to find these problems. So I also want to tell some background, which I like some terminology which I used. As you all know about the LLMs, but a couple another terminologies like a responsible AI. It's a concept for developing AI system in with the ethical principle. Also, the protected groups. It's some individuals or categories safeguarded by some law, regularizations, or some rules in the company. Can also be to against discriminations. And the part of the naming in my thesis was demographic biases is some projections or inaccurate in AI system influenced by individual demographic characteristics. If we will jump into related work, I mostly analyzed three main parts is related the generative AI with the limitations we have of the model and what's capabilities of a generative model we have in NLP. Also the part of responsible AI, how we evaluate our system, what best practices we have, and also we mentioned the separate part related to bias mitigation techniques in LLMs. And in this case, we have like a bit luck that we have some general understanding of different cases, but like some concept how we can mitigate. But there are not a lot of research for now which try to mitigate this system, this problem. So, and also I want to mention one work which is like the most interested in the related part. It is investigating hiring biases in large language models, which really applicable to my case. And as they try to evaluate these biases too, but they have like a couple of real limitations. That's whole protected groups which they use. It is like binary representations, and also their lack of job descriptions in input data. They provided to the model like informations about the candidate, like really simple, and also provided the title of the position for which candidate wants to go. And when we analyze all of them, we find in the research gaps related to the protected groups that mostly analyzed only gender or sometimes race, but ignoring some another characteristic as age, military status, and others, or their combinations. Also, we have language landscape issues. That's mostly all analysis is only in English, and we do not analyze in other languages. And it's related to the LLM's mitigation techniques. As I told, that we have mostly the detecting and evaluation, but not mitigating. And after that, we create a couple of research questions which we want to ask, like to answer. It's how do bias in LLM varies across different protected groups? How much does language awareness of LLMs influence fairness disparity in different protected groups? In our case, it will be English and Ukrainian because our data is only concentrated in these two groups. And the last one about to analyze this bias detections and mitigation, like knowing bias detection and mitigation techniques in the concept of AI-assisted hiring system. Before I start to tell all of the part, I want to have like a one slide related to general concept, how all works looks like. That we need to collect some sample of anonymized CVs and a job description, which we linked for our experiments. After that, we can like create the collections of protected attributes for each protected groups, which we can after that inject it into the prompt. Also, we like need to create some baseline prompt which can decide to hire or reject and provide the feedback why they do this. And after that, for the injection, we use this pair of anonymized CVs and job descriptions match with a different protected attribute and run it. And it looks like we have groups of this one, and we can analyze how they answer for different protected attributes. And after that, we analyze with some set of fairness metrics. And when we do this, we can implement some mitigation techniques and run it a couple more times. And after that, analyze also the effectiveness of these mitigation techniques. If we will talk about the smallest part of the sample experiments, that we have this recruitment data sets, protected groups, and after that injected into the prompt, execute LLMs and get the decisions and also the feedback. What I also want to mention is that for our research, we use GPT 3.5 Turbo. Why we use this model? Because it's like has a trade-off between their price and also the performance. And also they a bit good with the Ukrainian, which cannot do the mostly open source for now. And if we will jump into the evaluation metrics, we specified it into three main groups. This is fairness metrics. We implemented it as a ratio of predicting higher reject across protected groups per each attribute. The consistency metrics, which identify when the model provides a decision opposite to the majority decision for identical CVs. And also we have the explainability metrics, which we calculate as a, cosine similarity of feedback in the each groups, for each pairs in this group. And when we evaluated it, we can implement this mitigation techniques, and always we can specify it into three main groups. It is pre, in, and post-processing techniques. In our case, due to the time limitations and computational limitations, we analyze only the pre and post-processing. For pre-processing, it is like modifying the prompt, for example, or optimizing it, optimizing the parameters which we provided for the model as a temperature. Also, for the post-processing, it can be the different model re-ask, like second verifications or other re-ranking techniques. And in processing, is in general, I can tell that it can be like the fine-tuning, model architecture modifications, and some like creations of the agentic system. Uh, Also, if we will jump into the data sets which we used, we firstly try to analyze the open source data sets which we find, but they have some limitations. One of them that's they mostly was in English. Second limitation that if we can find some part like candidate CVs or job descriptions, it's not matched from the one platform or for one time period. So we collaborate with Jenny team and created the data sets related, which contain both job description candidate CVs in English and in Ukrainian. And we also publish this work as a separate one in UNLP 2024. And this data set also open with MIT license, which you can really like easy to use in your work if you need it. What we did with the data sets, we did some filtering process because we have some anomaly data. For example, user provides some not good text. For example, they do not delete their profile, but tell some like trash informations without any sense, which we dropped, and also we dropped some really similar data for our case because we do not needed it. And interesting fact is that from job descriptions we dropped near 60%. That's a user like a company created their data sets their job descriptions really similar to which they have before, and changing only like some rewriting something similar, but all other was same. After that, what we did, as our data set limited with matching, we created like a simple matching system where we try to match the job description and anonymize CVs to have this pair which we can use. Another part of another data set which we also created as a parallel for English and Ukrainian, it was a protected group corpus for the groups which you can see on the slide. Also, we can see we have more than 5,000 names. We get it from the Vasum dictionary, but for our experience, remains due to the cost and resource limitations, we used only 10 of them, randomly selected for male and female. Also, what we did the data sampling. Why we do this and do not run it for the whole data set? Because without sampling, cost of one experiment, for example, baseline, it's more than $6,000, and running with whole limitations of the OpenAI, it will be near 28 days, so it's really huge. So we get like a smaller part of this data set, and we selected 450 pairs per each language. And in this slide, you can see some simple examples how looks this data set. It's a pair of jobs, for example, the part which is related to some DevOps stuff mostly, and the candidate uh, candidate informations will also which related to some DevOps stuff, which we can see at the end, for example, cloud infrastructure and that. And the output example which we have, it is like we have the decision part, which can be hire or reject. And also we have this feedback which we provide for the user, and this example is get it from one of our parts view, and in the paper you can find the link to all of the parts of this data set with this ID. If you can be interested, you can find it. And if we will jump into our results, I now will show you two of the groups. One of them, it is a marital status. What you can see in the upper part, it's two plots related to the English language, and the lower part is related to the Ukrainian language. And in the left part for you, it is mean hire rejects, which mean how much we told hire or reject for different protected attributes. Um, and for the right part, it is part of the biases. How much we told for the users that they provided the informations opposite to the majority groups in this case. For example, from three of them, we told that we will hire them, but for one status, for example, civil union, we told that we do not hire them. And what we can also see is that we have a bit different pattern in Ukrainian and in the English languages. And also, for example, with the civil union, which we have a high bias level, but it's provided with a low, higher reject ratio. But it can be also in a different way. For example, and for the unmerit, merit, we have also high bias level, but it's also provided as a higher reject ratio. And what we try to do next, we try to implement some mitigation techniques. We use some which related to the pre-processing. It is like ignoring personal information we told in the prompt. Also ask to provide some reason, providing some recruitment guideline, like providing some chain of thoughts of optimizing the parameters. Or for the post-processing, we use the second model verifications. And for example, for the English case, what we want to see the example which will be really close in the higher reject to the in the to the baseline. Why we want to do? Because, for example, we use this baseline in our system, and we do not want to change it really bit as it's did for the ignore personal informations. And also we have want to have the lower level for the bias, and it can be this recruitment guideline which has a lower level of bias for each of the category, and also have really similar results for the higher reject ratio. For Ukrainian, we can see that this recruitment guideline is a bit different and don't fix it as in our case, but we have this another methods as ignore personal informations, which for example, good well in the Ukrainian part of the dataset. As we can, sometimes we can fix it, but if we have example with the military status, we can find a big pattern that, for example, for the English data sets, we have the participants in combat activities, and they have the much lower chance to be higher than the, like two times lower chance to be higher than the civilian. And we can also see this really big pattern in the bias. They have the highest one. And when we try to use some mitigation techniques, they do not fix it a lot, like this, like don't significant changes at all. That's why it's meaning that some simple changing of the input data or the output one cannot help for these situations. It's more for the using more complex as in processing for fine tuning. Maybe we'll fix it, or maybe it's needed to retrain the model and to be on this part of the creations of the first data sets, which should be unbiased. And so, what's the main conclusions of this work? That we develop recruitment data sets for the English and Ukrainian. We created like a methodology for benchmark it AI-assisted hiring system, and probably we can scale it to a different decision-making system. We can also evaluate biases and highlight this fairness issue for this system, and explore both pre and post-processing mitigation strategies. As our future work, we want to publish these results as a paper. Also, after that, we want to investigate it in processing mitigation techniques, and maybe also combine it with LLM tracing, for which a bit discussed Alexander today in his work, which can be helpful to easily modifications of the model, compares the different LLMs, maybe combine it with human hiring, and try to scale it, for example, for the different domains. The main comments from the reviewer from the first time we had that it was like more writing and related to some words, like to change some words. And I also really thanks to Sergey who provided the great list of also possible improvements which I can use in my future work. And yes, that's all from me. Maybe you have some questions.
So Nazari is the last. So we pretty have like unlimited question window. So like do not hesitate to ask.
Yeah, thank you for your talk. I have really short and small question. So in your work you used GPT 3.5 Turbo.
Yep.
Yeah. So and you created some mitigation rules that allows you to reduce this bias of the model, like at some point, like
Yep.
a
Yep.
bit.
Yep.
So you plan it to publish and to use it in the future. But from my understanding, the bias that ChatGPT, specifically the version that you used, introduce into the data, into the results, it's specific to the model that you used. So if you create the mitigation rules for the model, it means that they can't be scaled for the new models. So how do you plan to manage this? So to create mitigation rules that will help LLMs, because the topic of your work is not ChatGPT 3.5 Turbo, it's about LLMs.
Yeah, in general, we have some patterns of the data for which training this model, which we can find it and somehow modified or applied for the different models. Also, what is interesting is that we providing, like in general, the methodology, how we can run this system to verify it as a benchmark. So this list of improvements can be as your possible list of possible solutions which you can try for your specific situation, because also this will be not like if I told that, for example, a recruitment guideline is good for this hiring system, it can also cannot be good for another case, and we need to test it for another case one more time, all of these techniques, because it's different.
So you consider that it's possible that your rules, like you have a list of them, and some of them can work, and some of them cannot work, and in some cases, all of them cannot work. Like,
Yeah, yeah,
oh, so
sometimes this can happen.
okay,
Yeah,
cool.
because as you can see also with the military status which we can have, that we have this high bias level and it cannot fix it with this simple like techniques.
Okay, cool. Thank you.
Thank you for your presentation. Can we go back to the slide where you have shown the scheme of like of your approach? Uh,
Mhm. This one
yeah,
or
yeah. I
no,
think this one should work. So as I understand, as in your data set, you have labels of hired, rejected.
no, we do not have it, and that's why we created some simple matching where we match the candidate to the job description.
Mhm.
And also it's not so important for us to be like the ideal match, because we try to verify it's how good and how non-biased it for all groups, and it be more consistent and less biased for all of them. So if we will have some connections which is not correct and told us for them reject, we need to reject all of the candidates. And
Mhm.
sometimes we do not do this.
Okay, so you do not have like some ground rules like from
No, no,
recruiters.
no.
Okay, I see. And I think the next question, as I understand, like as you operated on Genie data sets, so this work is kind of biased to IT sphere.
Yeah.
So it's maybe you have you have taken a look at some other works, or you have some thoughts whether it can be like be applied to some other jobs and so on.
Yeah, yeah. We
Spheres.
also want to like have a small plans to try to get this resumes and ads from another platform, but it will be a bit more complex because Genie providing like this anonymized CVs, which we can easily apply. But for from another, it will be a bit harder, and maybe this data set will be not for like be applicable or open sourced if we will get it.
Okay, I see. And I think the last question, so you were mostly working with pre-processing techniques, as I understand.
Yeah, mostly was a pre-processing.
You have mentioned that there are some in-processing techniques like fine-tuning and maybe some preference optimization. But what about post-processing? Have you some ideas what can be done on
With
that
the
part?
post-processing, we tried the second model verifications when we ask like another model to verify and told if it's the result correct. Also, I think that is can be a good chance when we cannot like change whole of the system, and we can fine tune like simple weak model. For example, I don't know. For this case, can be BERT with head of classifier to identify if it's biased or not, and it will be like a bit simple system, but it's like don't need so much computational resources for the changing.
Okay, thank you.
Yeah, thank you for presentation. My question is, what temperature do you use for your GPT to make a decision?
For first baseline, we use it as zero. For no, for the baseline, we use it as 0 0.5 as the default one.
Mhm.
And after that, we do some optimizing parameters and optimize it and also analyze with them.
Yeah, and so my question is, uh, so you do analyze the dependency between temperature and bias?
Yeah, I also have this. I can show. Mm, For this case, it can be this yellow line.
Mhm.
It is concepts with yeah, the yellow.
Yeah, I
No,
see.
no, not yellow. Yeah, it's yellow because optimizing parameter and second model verification overlapped. So they have like the similar results. That's why this yellow, it's this optimizing parameters which we have.
Okay, thank you.
Yes, thank you for your presentation. I want to extend the question regarding the bias of the data set itself. So till the couple of last years, I believe, for example, in our countries, there was a list of professions that was unable, for example, for women. And with your technique, there would be a great bias toward such professions, like something like you showed with the military part. And that would be not correct to mitigate it.
It will be part of the historical bias, which we cannot fix with one part, but mostly in this data set, we selected like works which are mostly applicable for all groups. For example, data scientists, also some JavaScript developer, and that's
Okay,
like the most popular one.
yeah, I got it. So my question is, like, have you thought of the way how to generalize it?
Mhm.
Sure.
We can It's hard questions to be truth. For example, we can also generate some synthetic data for some of this category which are really weak. For example, of this group, if you can.
Mm, not sure, but it's like seems to be like a fun research.
Yeah, yeah, I agree.
Okay, thank you.
Thank you, Nazari. Really interesting and useful research, but I didn't get several moments, so can we go deeper?
Yep.
Can you please open the slide with this baseline experiments when you show us bias analysis for higher region? Yes, this one.
Yep.
So first of all, sorry to mention this, but the charts are unreadable. Even I'm sitting with my glasses
Oh.
and on the first row, and I cannot read the X description.
Oh, I can read if it's needed. It's first one. It's civil union.
Can you zoom in on
Yeah.
your? Yeah, but I can read in your thesis, but I'm not sure whether audience other rows. Yes, that's much better. So let's stick. So for instance, let's start with high reject ratio. What does it mean? How to treat it? This number. So for instance, we take this merit like it, and it's 0.5 for something. So how to treat this?
Mhm. In this case, that's told like we have the whole data set for which we run it, and we run it for each of the category. For example, anonymized CV's job descriptions plus providing this status as a marital, and we have it for each of our pairs in English. It's 450. We have it 0 or 1, and after that calculated it as a mean value, which told us the higher like higher value told us that it's bigger chance to get the more often in the data sets we told higher for this person and lower to reject.
I want to elaborate on this higher verb that you said. So you told us that you artificially matched like applications with the jobs.
Yep.
And as far as I understand, you do not have information about whether it was high or not.
We have it by generated by the model. That's why we want to have it
Stop.
more consistent.
Sorry for this. So what does it mean? You have it generated by model? Is it artificially generated?
It was this example for which we generate. Like we do not have the value, but it's example. It's like the output of our system. They told us to hire or reject person, and after that we
So
calculate.
you have data from Genie, which
Yeah.
is actually you described as the data. It's applications and job descriptions.
Yeah.
And you do not have information about whether it was hired or not.
Yeah, as a golden true, we do not have it.
And how you generated this variable?
It was like this main concept of this experiment that we ask model to generate the decision to hire or reject person, and also provide them the feedback. Why we can do this and we do not.
And then based on these generated values, you build these charts.
Yeah, and for this one, which we want to have the more consistent for each of the.
Yes, we want to be
attributes.
at linear
yeah,
equal.
much
Yes, I
the
see
most
it.
equal.
Okay, and then if we get to the right part, so can you please zoom in again? So this bias, so how do you calculate this bias value?
Yeah, for this one, for example, we run experiment for each attribute for these pairs of anonymized CVs and job description. We calculate the majority group. Like, for example, for 3 of them, we told higher, and we put like one, provided one for the another if it's not the majority group, that we told them another opposite decision that's for for the majority of this like linked anonymized CVs and job description.
And in ideal situation,
It will be 0.
we want to be at 0.
Yeah.
Everyone, I mean
Yeah.
that. And for that reason, you can, by your methodology that you used, we can find the most biased groups.
Yeah,
Is it
yeah. For
correct?
which we told the highest bias.
So I'm looking at the figure 5.3 in your thesis. It's about military status.
Yeah,
And that it means that participants in combat
have it.
actions have the highest
Yeah.
bias. Have you interpret this data, these results? So why do you think you got these results?
I think that's model do not maybe trained on the data which related to the like the about
the problem,
person of the
yeah, let's stick to
military.
this one. I picked it randomly because the highest.
Yeah, it's the highest difference.
Yes, but it's interesting to think. So let's have a discussion because Ruslan said that we are not limited in time.
Yeah, I agree.
So on one side we can have bias in the data. On the other side we can have a bias in
model.
In the model, and we know that GPT. And you used which one?
3.5 turbo.
Yeah, so they are biased, and actually we like working with the GPT 3.5. We're not working with the pure model. We're working with the AI system with all those restrictions created by developers.
Yeah,
and we know that they try to eliminate all this harmful content.
Yeah,
and could it be the reason that because of this elimination, model try to put less like chances for those who are military combatants?
In general, maybe, but when I check the feedback also, which is generated, it looks maybe a bit logical that they told that we cannot
But
hire
you
this
know, when
person
you come
because
to
first.
HR and specialist, she will respond to you with really logical. Even
Yeah.
when we will put you a grade after this defense, we will respond logically. But
Hmm.
still, we are biased.
Yeah, it's true. That's why model also biased. And we want to like to fix it to have a model better than us for the
Okay,
decision.
thank you.
Yeah, so also prepared a couple of questions. So first, I wanted to ask, what is the range of the mean bias? What is the minimum and maximum value possible?
From 0 to 1.
And your scale is a little bit not fair.
Yeah, we scale it to understood like this difference for each of them.
Yeah, but it's if you put a scale from 0 to 1, it will be a straight line.
It
Can
will
you?
be really close to straight, but we do not see. We will do
So
not see this
there is
difference.
no difference. Can you please zoom, for example, the bottom right plot?
Uh, but,
Bottom right.
mm,
So it's like no changes.
but if we scale, we understood that
So
we
it's
have the
zero.
changes.
It's misleading. Is it so your title range is misleading. Um, Also, I'm curious about, so you mentioned that you are checking like Ukrainian and
English.
English models. And for example, I would be curious to know if like this is hiring decision is language dependent. So have you maybe tried translating Ukrainian job postings to English and checking the decision, the bias, is it different between English and Ukrainian like languages?
In this case, we do not do this. It's like also a problem that if we will translate it, we have a bias from the translation. And that's why we have two data sets. And it's the easiest to analyze only this
What is the
bias.
bias of translation? If, for example, I translate the job posting, like it's ground truth translation.
No, it's providing, it can provide some errors of of the translation, which model can understood that it's a problem. And I need
Okay.
to verify it like manually or some annotator which can help to analyze these troubles.
Uh, okay. Also, could we please go to slide number 5? So your motive, 4, please 4. So it's slide number 5. Yes. So what is the date of these articles?
Uh, for this one in 2024, it's
And maybe so I noticed like 2018 or something. Maybe.
uh, no, the 2018 we
Okay.
have for
Okay, agree.
the
They're pretty recent.
for this case for
Yeah.
the
Yeah.
for
So
the
this case, it's like not valid because this models change so rapidly. So
yeah, it's like the most common cases of these biases. That's why I'm showing it.
okay. And yes. Okay. So I don't have more question. If anyone from examination committee, then thank you, Nazar.
Thank you.
Infinite break. So we need like up to 1 hour to consolidate, half an hour, sorry, up to half an hour to consolidate our grades, and then we'll be ready to announce them. Up to, from 0 to 30. 3:30.